Okay, briefly, who I am and why I'm here. I am a former engineer from the military space program. I entered that program a number of years ago as an evolutionist and an atheist. I came out of it a creationist and a Christian. And tonight I'm going to share some of the things I learned during that time and since, and try to convince you of my beliefs now as well. See, so I'm going to indoctrinate you. But I'm warning you up front, so it's ethical, right? You've sometimes been told, I'm sure, as I have, that we're creationists because we're Christians. In other words, if we weren't hampered by our Christian beliefs, we would see the obvious truth of evolution. I am one among many who, for the opposite is true. I became a creationist first and a creationist after. So what I'm going to talk about tonight, and the time we have, is, as you can see, our created solar system, what you are not being told about evolutionary astronomy. Let me explain my use of the word evolutionary first. Most people use the word evolution to talk about biology. That's, of course, the most common use of it. You also hear it applied to other objects as well that aren't based on life. So when I talk about evolution, I'm talking about the idea that everything around us, the entire universe, formed all by itself without the intervention of a creator. If I can figure out how to work this thing. Click. Now, there's two opposing views as to where the universe came from, the Bible versus the Big Bang. The Bible says everything was created in 6 days, about 6,000 years or so ago. Every object in the sky was created for signs and for seasons and to glorify its creator. The Big Bang, on the other hand, says that everything formed all by itself billions of years ago with no creator necessary or desirable. Everything is explainable by current theories. Now, the basic theme of tonight is that although we are told constantly over and over and over again that science has it all figured out, that evolution is the answer, that there are no problems in this theory whatsoever, I'm here to tell you that's not true. We're going to talk about a lot of the problems, I shouldn't even say a lot, some of the problems that exist in an evolutionary view of astronomy today. As you can see, I have a picture of the solar system. This is not to scale, of course. In reality, it would be spread out much further. Obviously, there's a sun in the middle. Going outwards from the sun, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and out here is the orbit of Pluto, Pluto being the furthest from the sun. We're going to limit our talk tonight to these objects. There's a lot more within astronomy we could talk about, obviously, but this is all we have time for tonight. We're going to go through each of these planets and show that each one, in a unique way, disproves evolution. And when you are being told that evolutionary astronomers have it all figured out, well, you can judge for yourselves what to think of that opinion when we're done tonight. The standard model, according to evolution, says that our solar system formed billions of years ago from a large swirling cloud of gas and dust. This cloud is usually called a nebula. Thus, this is called the nebula theory. You might hear that phrase being used. So the nebula began to rotate as it was swirling. As it rotated, it also flattened into a disk. A central bulge in the middle formed as it was rotating and became our sun. Smaller collections of material around it then became the planets. So here's an artist's conception of what this might have looked like. Is there a way we can lose the dinosaur, Bruce? Am I doing something wrong?
I think you must have. Oops. There I go. Okay, you want to go back?
Thank you.
Okay.
Yeah, galloping dinosaurs aren't really appropriate, but that's Saturday morning, right? The dinosaur talk? Yeah. Okay, so here's an artist's conception of what the early solar system used to look like according to evolution. You see there's this big swirling cloud of gas and dust. There's the central bulge in the middle, which is already forming into a sun. Notice here there's rocks forming. I'll talk about that in just a minute. Notice also that this whole thing is a flattened disk. It's no longer a big circular cloud. It's flat and rotating around the forming sun. Now, as this gas and dust coalesced, larger grains of dust formed within it. These stuck together to become rocks, and the small rocks stuck together to become bigger rocks. And the bigger rocks stuck together to become what are called planetesimals. That's a word that you'll hear a lot in astronomy, but not really anywhere else. So I'm going to use the word asteroid tonight when I talk about planetesimals, but it basically means big rock in space. So the asteroids formed from the smaller rocks, and they stuck together to become planets. So that's where the planets come from. And here's an artist's conception of a later stage in that process. You see we have a nice sun out here, we have a nice planet here, and there's still a lot of rocks forming, in some cases colliding with each other. But eventually they all stuck together and they all became planets, and that's where we all came from. So this basically is the hero of the story. This is a real asteroid in space today, but I'm going to use it for illustration of what a planetesimal looks like, one of these early rocks that isn't quite a planet yet because it still needs to stick together with a couple of its brothers and make planets. So, basic idea is gas and dust stuck together, make rocks, rocks make bigger rocks. They eventually turn into these things, asteroids basically, and then the asteroids stick together and become planets. Well, there's only one problem with this model, and that's it doesn't work. Oops, I'm getting ahead of myself. Okay. Evolutionists will tell us that proof, quote unquote, for this model is that the theory explains the flat shape of our solar system. I showed you how everything turned into a disk, and indeed in our solar system today, all the planets do rotate or orbit around the sun in a disk sort of shape. Obviously, there's no physical shape there, but you know what I'm saying. All their orbits, with the exception of Pluto, which we'll talk about, all line up with each other in what is called the plane of the ecliptic. So this model explains the plane of the ecliptic and the fact that all the planets' orbits line up with each other. It also explains the fact that all the planets orbit counterclockwise around the sun. It also explains the fact that the inner planets closer to the sun are rocky, whereas the outer ones are made of gas. Part of this model says that the closer you were to the sun, the hotter it was. Well, that's not brain surgery there. But the higher temperature made it impossible for water and volatile gases to condense. Thus, the only things that could condense out of the cloud close to the sun were rocks. The further away you got from the sun, however, the cooler it got, and so you can have larger gas planets like Jupiter and Saturn and so on. Is everybody with me so far? Or am I getting too detailed? Okay. Minor detail with this whole model is that it doesn't work. You can model how gas and dust will stick together to make bigger grains of dust, and you can maybe even get small rocks out of it, but you can't get the planetesimals to stick together into planets. Here's a quote as an example from a man who actually believes this model. Once these planetesimals have been formed, further growth of planets may occur through their gravitational accretion into large bodies. In other words, the planetesimals, after they get big enough, start having their own significant gravitational field, and as they pull on each other, then they'll accrete, they'll stick together and make planets. But just how that takes place is not understood. So incidentally, this is from an astrophysics textbook on page 553. So you wade through 500 pages of all the dust and the grains and all the rest of it. Then you get to the part where the miracle happens. And then we skip on and go something else. So it makes you feel that your first 500 pages have really been a waste of your time. But we'll skip that. Now, let's look at the evidence without preconceptions as to whether or not evolution or creation or whatever happened. And we're going to ask the question, with all the things we actually see in the sky, I mean, throw out the theoretical models about what may have happened. Let's look at what's in the sky right now and ask which model do these things support. Do they support the idea that a solar nebula formed from gas and dust billions of years ago? Or do they support a more biblical model which says that the solar system was formed recently by an intelligent creator for signs, seasons, and to demonstrate his own glory? We will start with the planets closest to the sun, called terrestrial planets because they're like Earth, they're rocky and not the big gas planets. We have Mercury, Venus, Earth, and Mars. We will take them one at a time. We'll start with Mercury. Mercury is the closest planet to the sun. It's tiny. It's smaller than all other planets except Pluto. It's even smaller than Ganymede and Titan, which are moons of Jupiter and Saturn. Being so close to the sun, Mercury is a rather hot place. If you are on the side facing the sun, temperatures get up to 840 degrees Fahrenheit. On the other hand, if you're on the side away from the sun, temperatures go down to minus 180 degrees. So very big temperature differentials there. Now, it looks a lot like our moon. It's small, it's rocky, it has impact craters from where things have hit it, and so on. This picture here, incidentally, is colorized. All of our photographs, for the most part, came from the Mariner 10 space probe, which took black and white pictures. But from subsequent analysis, scientists have figured out that if we had taken color pictures, they would probably look like this. The streak here, by the way, is a spot where we don't have photographs for. So that's not actually part of Mercury. So here's what the planet looks like. Now let's see how well it fits with the evolutionary model. Mercury is a little planet, but it's given evolutionists some big surprises. First occurred when the Mariner 10 space probe first visited Mercury. We measured the planet's gravitational pull on the probe, and we took some other measurements at the same time. We discovered that Mercury is extremely dense. There's a lot of material in a small space in Mercury. In fact, it's the highest known density of all planets except Earth. The problem is Mercury is too small to have such a high density. It's small enough to where it doesn't have a large gravitational field, thus should not have compacted all the material to such a density. In fact, we believe that up to 75% of the radius of Mercury is represented by an iron core, which is this thing here. So in this little cutaway view, if this is the planet, then this is one big ball of iron on the inside. So Mercury is mostly a big ball of iron wrapped in a few rocks. Now, this is a big problem for evolution, though. Evolutionary nebula theories say that Mercury can't be this dense, not even close to it. And this has caused evolutionists all sorts of fits trying to accommodate it into their model. Here's a quote from an evolutionist. He says, "The driving force behind previous attempts to account for Mercury has been to fit the high density of the planet into some preferred overall solar system scheme. It has become clear that none of these proposed models work." And the high density, so how do they explain this? Okay, Mercury doesn't fit into the evolutionary model. Well, the high density is conveniently accommodated by the large impact hypothesis, which makes Mercury unique. Well, what is a large impact hypothesis? Basically, it's the idea that since evolution can't explain Mercury, because the planet has to be far less dense than it is, therefore, since we know evolution is true, Mercury must have formed according to the evolutionary model. But early in its history, one of those asteroids that we saw circling the sun crashed into it. Now, all the lighter material was stripped away and dissipated somehow, leaving behind only the dense material that we see today. Okay? So Mercury today doesn't match evolution. Since we know evolution is true, therefore it must have used to match evolution, if I can butcher grammar a bit. But an asteroid crashed into it and changed it to what we have today. So where's the evidence for this collision? Well, back up a minute. This is the solution to the problem, okay? One of these asteroids that we saw earlier forming along with the planets smashed into Mercury, and all the stuff that should have been there just went away somewhere. So what's the evidence for this model? Well, only that if it didn't occur, Mercury would disprove evolution. Anybody see a problem with this? But that wasn't enough. Mercury gave evolutionists another rude jolt when Mariner 10 also discovered that Mercury has a magnetic field. Problem is, according to evolution, it can't have a magnetic field. And to explain why, I'm going to get into some geek stuff here. Forgive me for a minute. The only way for a planet to have a magnetic field, actually back up, the only way for a planet with a magnetic field to be billions of years old is currently known as the dynamo theory. The dynamo theory says that there is liquid inside of a planet that conducts electricity, and it's moving around, and that motion creates a magnetic field. And I won't get into details because it's a complex thing. The important thing for tonight is that it requires that all planets which have magnetic fields also have cores made up of molten metal that's melted, liquid. And as I said, fluid motions inside this liquid core can supposedly generate a magnetic field around that planet, which, like I said, is a complicated process. I won't bore you with details. So let's summarize that up here. In order for a planet to be billions of years old and still have a magnetic field, there must be fluid motions inside of its core. Therefore, the core itself must be molten. It has to be fluid. But, as one evolutionist says, Mercury is so small that the general opinion is that the planet should have frozen solid eons ago. Therefore, Mercury's core cannot be molten. And so evolutionary theories say that Mercury can't have a magnetic field, but it does. Now, I probably lost at least some of you in the details there, but the important thing is evolution says there can't be a magnetic field, and when we sent a space probe to visit that planet, it did have one. So how do they get out of this? Well, here's the proposed explanation. A pure iron core would have frozen long ago, like I just told you. So the most likely candidate is an iron sulfide core. In other words, the core isn't pure iron, there's some sulfur mixed in with it. The presence, okay, now, sulfur would allow the core to cool more slowly, okay? But the presence of the volatile element sulfur as a constituent of the planet closest to the sun, and I'll wade through the jibber-jabber here in a moment for you, has important implications for models of planetary accretion. If mercury contains a substantial sulfur content, then this removes much of the rationale for heliocentric zoning of nebular composition. I'll read the rest of it. Models in which mercury accretes from high-temperature components only are no longer viable. If the innermost planet has a substantial volatile component, there is little basis for condensation models of planetary accumulation based on heliocentric distance. What does all that mean? Well, if you think of when I told you about that big swirling cloud of gas and dust and how the closer you are to the sun, the hotter it is, and so certain elements can't have condensed into planets there. Well, one of those things that can't have condensed into a planet is sulfur, because sulfur is very volatile. So to rescue mercury for evolutionary theories, mercury has to have actually, today even, sulfur in its core. But the whole nebula theory says that you can't have sulfur in a planet that close to the sun. So let's summarize this. In order to preserve a billions of years age for mercury, evolutionists speculate that it has an iron sulfide core. But the nebula theory says volatile elements like sulfur can't be this close to the sun. So in trying to rescue mercury for their evolutionary theory, they've undermined the entire theory. Did my mic just go? It went out for a minute. Now, as creationists, we don't have a problem with this. There are other methods for a planet to have a magnetic field than the dynamo theory. The problem is none of them can last for billions of years. It's very possible that if Mercury was created with a magnetic field initially, that field could still be there today in the form of remnant magnetism. And actually, that explanation makes sense for a lot of the planets, as we'll see as we go. But the only way to get one that lasts billions of years is this dynamo theory business that I just explained to you. And Mercury says, doesn't work. So here's what you aren't being told about Mercury. Next time you see a science program about Mercury and how it evolved, this, that, and the other, here's what you aren't being told. Number one, evolution says it can't be dense, but we found out it is. Number two, evolution says it can't have a magnetic field, but it turns out it does. And trying to rescue evolution from the facts just makes the problem worse, as we saw. When you change your model of Mercury to make it fit in the billions of years, then your entire theory blows up. Mercury is indeed the tiny planet that causes huge problems for evolution. 1 Corinthians 1:27 comes to mind, but God has chosen the foolish things of the world to confound the wise, and chosen the weak things of the world to confound the things which are mighty. Next to Mercury, further out from the sun, is the planet Venus. Now, if you look at Venus in a telescope, you won't see anything like this picture here. This picture is actually generated from measurements we've taken of the planet's surface underneath its cloud cover. Venus actually looks more like this because Venus is totally covered in clouds. In fact, those clouds make Venus a very unpleasant place to be. The atmosphere is mostly carbon dioxide, and the clouds are mostly concentrated sulfuric acid. So you don't want to be breathing the air in Venus. The carbon dioxide causes a massive greenhouse effect, which makes Venus actually the hottest place in the solar system. It's not the closest to the sun, but it is the hottest place. 900 degrees Fahrenheit on the surface of Venus. There have actually been a few spacecraft landed on the surface of Venus. They don't survive very long, a matter of a couple of minutes. If you can imagine trying to engineer something that when you land it, the solder starts dripping out of your circuit boards, you can appreciate the engineering problem that these people had. But we have actually, as I said, landed a few. The Soviet Union, back when it was still around, actually did more with Venus than we did. The pressure on Venus is 90 atmospheres. So if you imagine a place where you're breathing sulfuric acid, you're in a nice cool 900 degrees Fahrenheit and being crushed by 90 atmospheres of pressure, the biblical description of Hades comes to mind. Now, Venus is often called Earth's sister planet because it's very similar to the Earth in the size, mass, the stuff it's made up of, and its location in space, because we're right next door to Venus. Now, evolution says that Venus should actually be very similar to Earth because both planets supposedly formed at the same time, at the same place, from the same materials, by the same natural processes. So since there's no interference by a creator, they should be roughly the same, right? Well, they are similar, as I said, in size, mass, and composition, but Earth has a crust made up of multiple tectonic plates. Venus only has one. So there's a glaring dissimilarity in the structure of these two planets. Also, Earth has a magnetic field. Venus, as it turns out, has none. They've looked for it. It should be there, but it ain't. So even though the dynamo theory says that it should have one, it doesn't. Other problems for evolution. Venus's surface is very young and fresh. It doesn't have billions of years of erosion, apparently. The few spacecraft that survived long enough to actually send back pictures showed rocks with very sharp edges. Now, if you imagine a rock at 900 degrees Fahrenheit, it doesn't melt into liquid, but it does sag and get soft over time. So Venus, if it's billions of years old, should have evidence of this billions of years on its surface. It doesn't. Another big problem that shocked people back in the 60s when it was first discovered is that Venus rotates backwards. In other words, here is how the planet rotates today. If you were on the surface of Venus and could actually see through that cloud cover, which you couldn't, but assuming you could, the sun would rise in the west and set in the east. Venus rotates this way, whereas it's supposed to rotate that way according to evolutionary theories of how all these things got there. So how does evolution accommodate this? Well, you see, Venus did form according to evolution, but then a long time ago, things happened. The original explanation was that there was gravitational braking on a tidal bulge. In other words, there was a bulge on the surface of Venus that gravity from other things grabbed a hold of and slowed it down and spun it around the other way. But then we found out Venus doesn't actually have a tidal bulge. It's almost perfectly round. So today's explanation is that Venus did form as predicted by evolution, but then an asteroid hit it and spun it around the wrong way. So here again we see the solution. So where's the evidence for the supposed collision? Well, Venus's axial tilt, in other words, its tilt relative to the ecliptic plane, is only 2 degrees from being perfectly perpendicular. If something had smashed into Venus, you would think it would knock it over a little bit. I mean, if something hit it hard enough to spin it all the way around the opposite way. Also, its orbit is the most circular in the solar system. It's circular out to 2 decimal places. No evidence for any collision whatsoever. Oh, but there is the fact that otherwise Venus would contradict evolutionary theory, so we know it's true. So, here's what you aren't being told about Venus. Evolution says it should be similar to Earth, but it has no magnetic field, and its crustal structure is very different. Its surface is obviously young, and it inconveniently rotates the wrong way. Now we'll go on to the planet which is near and dear to all our hearts, it being home and everything, Earth. Earth is uniquely designed for life. There are conditions here that we've not found anywhere else in the universe. First of all, our rotation period, in other words, how fast we spin on our axis, which determines how long our day is. Currently it's 24 hours, but there's no reason it has to be 24 hours, right? Times in the solar system go from 10 hours out to, I forget the number off the top of my head, but it's, I believe, 200 some odd days. So, and I hope we can edit the tape if that's wrong. But anyway, there's no reason our day has to be 24 hours long. However, if our day was too slow, that would mean extreme temperature changes because one part of the planet would be facing the sun for a lot longer than the other side. So it would be really hot on one side and really cold on the other side. On the other hand, if we rotated too fast, we'd have violent winds on this planet, which would make life here impossible. Our axial tilt is moderate, which gives us moderate seasons. Again, there's no real reason for that. Axial tilts vary dramatically all over the solar system, as we will see, but the one we have been blessed with gives us very moderate seasons. We also have a nice circular orbit, which gives us stability in our climate as we change from seasons to seasons. And none of this should really surprise us because Isaiah 45 says that the Lord himself has formed the earth and made it. He has established it. He created it not in vain. He formed it to be inhabited. So God made it for us to live here. So we shouldn't be surprised that it's perfectly suitable for us to do that. We also have a nice atmosphere surrounding our planet. It nurtures us, protects us from deadly radiation on the one hand, gives us air to breathe on the other. And this, again, can be a widely varying characteristic across the solar system, but ours is just right. If we had a thicker atmosphere or one that had different gases in it, we would have a runaway greenhouse effect just like Venus does. On the other hand, if we went too far in the opposite direction, we could have runaway glaciation and be living on a big ball of ice. So our atmosphere is just right. We also have been blessed with a tremendous amount of water. About 70% of the Earth's surface is covered by water. Water is, of course, necessary for life. It's also unusual, at least from an evolutionary perspective, because none of it should be there. Remember we talked about that swirling cloudy gas and dust, how certain things can't have condensed close to the sun. Well, we're too close to the sun to have all this water. So where did it come from? Well, we didn't used to have it, but After everything was formed, comets and other materials that had water came in and hit us. Now, time for a question. I don't know how much the various speakers this weekend will be getting into Noah's flood. There are certainly enough materials out in the book tables out there if you're unfamiliar with all the evidence for a global flood. But the Earth has more than enough water to flood its entire surface. This isn't really a main point of my talk, but I wanted to mention it while we're talking about water. There's lots of evidence a global flood has occurred. And again, if you're unfamiliar with that idea, I'd recommend some of the materials on the book tables to you. However, such a flood is considered unscientific because it is a non-repeatable catastrophe, and there's no experiment you can do in the laboratory to prove that an event in history has happened. Well, it's true that you can't perform experiments, but there is a lot of evidence for it, and we will see in just a few minutes how consistent the evolutionists are when they criticize us for this part of our model. Quick question, though. How much water is there really on the surface of the Earth? I mean, people, you tell them you believe in the flood of Noah, and they say, well, where'd all the water go? Obviously, there's not enough water to flood the Earth because we live on dry land. Well, if you were to squish down all the mountains on the Earth and you were to push up all the ocean floors so that the Earth's surface was perfectly smooth, obviously the water would cover the Earth, right? Because there's water. If everything was smooth, there'd be nowhere for it to drain into. It would just distribute itself across the whole globe. How deep would that water be? And the answer is over 1.5 miles. So we have more than enough water to have flooded this entire place. The only thing that is different now than it was then is that we have deeper ocean floors and slightly higher mountains. Probably before Noah's flood, the Earth was a lot different. Since all the mountain ranges have fossils on their very tips, all the mountains used to be underwater. That's not to say that the water used to be the depth of Mount Himalaya, but it is to say that the mountains used to be a lot lower, and the ocean floors probably were a lot higher. Psalm 104, incidentally, talks about the waters draining down off the land into the place where God assigned for them. I personally believe that Scripture is talking about the flood. Anyway, wanted to mention it here while we're talking about water. We also have a very protective magnetic field. Now, I've mentioned magnetic fields a couple times already. This helps us in living here. Not only does it allow us to use compasses and so on, but a lot of wildlife uses our magnetic field also. Birds and butterflies and all those things that migrate thousands of miles, they're apparently able to sense the magnetic field somehow and navigate by that. The problem from an evolutionary perspective, I've already told you that Mercury shouldn't have a magnetic field but does. Venus should have one but doesn't. Well, they can't explain why we would have one either. I told you about the whole dynamo theory. I didn't give you any details. That's because the details are actually kind of lacking. What causes our field? Supposedly, like I said, fluid motions inside the core here are swirling around and causing a magnetic field. The problem is this theory doesn't work, and not only does it not work for the other planets, it doesn't work for this one, and this one is the one that the theory was invented to explain. Here's a quote from evolutionists. The mechanism for generating the geomagnetic field remains one of the central unsolved problems in geoscience. So when the evolutionist tells you he has it all figured out, pull a compass out of your pocket and say, well, how come this thing turns when I do this? Seems pretty simple, right? I mean, pretty basic thing to be able to explain if you say you have it all figured out. In fact, it gets worse for the evolutionists because since we first measured our magnetic field in 1829, its total energy has fallen by 14%. It apparently loses half its energy every 700 years or so. This has been confirmed by archaeomagnetic and paleomagnetic measurements, which, to explain the jibber-jabber there, archaeomagnetism is when you take human artifacts from a long time ago and measure imprints on like rust particles and stuff baked into clay pots or whatever. When you bake a clay pot, it turns out, and you heat things up to a certain point, the magnetic field that object is in will actually be imprinted on metal particles in the clay. So by taking old clay pots, we can measure magnetism in those little particles and figure out what the Earth's magnetic field looked like however many hundreds of years ago we're talking about. Paleomagnetism is doing the same thing, but with things that aren't human artifacts, like a lava deposit or something. So, point is, we can measure older magnetic field imprints, and these not only show that total energy is falling, but they show wild fluctuations of polarity in the past. Our field has been swinging in polarity, in other words, north and south reversing directions, violently sometimes. It turns out, because of all this, our field can only be tens of thousands of years old, not billions. And dynamo theories can't explain any of this, incidentally. That's why it led this particular evolutionist to say, magnetism is almost as much of a puzzle now as it was when William Gilbert wrote his classic text concerning magnetism, magnetic bodies, and the great magnet Earth in 1600. So 400 years later, we're still trying to figure it out. So here's what they aren't telling you about the Earth. It's uniquely designed for life. Its rotation period, axial tilt, orbit, atmosphere, and many other things. There's plenty of water here for the flood, even though evolution says it shouldn't have any at all. And the magnetic field can't be billions of years old. Now, we have a neighbor, our moon. The moon is also uniquely designed. It's close enough so that its gravity creates tides in our oceans. This actually prevents the oceans from being stagnant. The tides, as they come and go, help the ocean to circulate and prevent stagnant water and layering and all sorts of other things. I'm not an oceanographer, but this is what the experts say. Conversely, if the moon were significantly closer, the tides would be too much and harmful to us. Imagine having a tsunami on the coast twice a day. Wouldn't be a good place to live. So the moon's placement and its effect on us actually helps this be a nice place for us to inhabit. And the moon is, incidentally, at exactly the right distance to produce certain kinds of signs and seasons. I'm talking about solar eclipses. Now, the moon is much smaller than the sun. It's only 1/400th the size of our sun. However, by an amazing coincidence, the sun is 400 times further away from us than the moon is. As a result, the apparent size of the moon and the sun are exactly the same as viewed from the Earth, which is why, as the moon goes around the Earth, sometimes it winds up in between us and the sun, and we get solar eclipses, which I'm told, I've never seen a full one, but I'm told that a full one is an awe-inspiring sight. Now, there was an article written a while back trying to calculate the chances of this happening just by random coincidence, and, it's ridiculous. Nothing else in the solar system even comes close to the system we have with the Earth, the moon, and the sun, the way it's all positioned. The moon is also uniquely studied. It's the only other object besides Earth that people have actually landed on and walked on. The famous photograph of Neil Armstrong. But we went there to do more than just plant a flag and say, wow, this is nice. We also wanted to study this thing, to explore as much of it as we could. First of all, you'll notice large dark areas on the moon here. Those are called maria. It is believed that these are the lunar equivalent of lava, where something hit the moon hard enough to actually crack the crust, and lava oozed out of it to fill in all these basins, and then after it cooled, it's a different color than the rest of the terrain. You can see the lunar terrain by itself is fairly featureless, but when you see the intersection between some of the maria and some of the highlands, you can see how this looks like these mountains were here earlier, and then it was all filled in by this material, which sort of flattened it all out and cooled. Now, the interesting thing with the moon is, I showed you a moment ago, let's see if I can go backwards in this thing. Hey, it works. I showed you a moment ago that this side of the moon has quite a few of these maria, and depending on where the sun was when you take the photograph, these maria are either accentuated or diminished, depending on how the light falls on them. But other photographs of the moon will actually show more of these than this, large areas covered in this material, indicating that this side of the moon was beaten up pretty bad at some time in the past. Well, you would think then that since this all happened over billions of years from all these planetesimals crashing into each other, that the opposite side of the moon should look the same way. But when we first started flying spacecraft around it, we were surprised to find that it isn't. There's craters on the opposite side of the moon, certainly, but there's no maria like this. So the moon appears to be asymmetrically beaten up. Something whacked this side hard a good couple of times, and not the other side. Now, does this seem like the moon was going through this cloud of asteroids for billions of years, in which case, through random chance, you would expect they would be evenly distributed? It doesn't seem to work that way, though. One of the big questions that the Apollo missions were meant to answer is, where does this thing come from? part of the astronauts' job while they were walking around was to take samples. This is Apollo 17 astronaut Harrison Schmitt, who was actually a trained geologist taking samples. And they brought back hundreds of pounds of moon rocks, which we put in the laboratory and analyzed them and did all sorts of fun stuff. The Apollo missions were supposed to answer this important question: which one of these three theories is correct? At the time the Apollo missions went up, there were three competing theories: the fission theory, the nebula theory, and the capture theory, each one of which claimed to explain where the moon came from, and Apollo was supposed to help decide which one was correct. Let's talk about each one of them. The fission theory says that the early Earth was spinning rapidly, and that as it was spinning, a chunk of material tore off of it and became the moon. And in some variations of this theory, the Pacific Ocean basin is actually the place where the moon came from. So that big spot on the Earth where there's no continents, that used to be stuff there that tore off and became the moon. The problem with this theory is that when the astronauts actually brought back some rocks, they found out that Earth rocks are different than moon rocks in some very important ways. The moon is deficient in iron, for example. And if the moon actually used to be part of the Earth, then the rocks should be the same, right? Also, there's a problem, too. The Earth would have to have been spinning very quickly for this to have taken place, somewhere around 2.5 hours for the Earth to zip around on its axis once, where what now takes 24 hours would need to have happened in just about 2.5. So the Earth would have had to have been spinning very, very fast. The problem is, where did all that excess rotational energy go? Because obviously today the Earth is spinning only 1/10 that fast. Somebody commented on this and said if the rotation of the Earth had been slowed by tidal friction from 4 hours to 24 hours, there would have been an energy dissipation of, big number. Such an energy release is sufficient to raise the temperature of the entire Earth by 1,000 degrees Celsius. In other words, to slow the Earth down, there's a lot of energy that's going into spinning it that you got to take away and has to go somewhere. If that was dissipated by friction among the tides in the Earth, as the theory says, this guy calculated that all that energy going into the Earth itself would have raised the temperature of the entire Earth to 1,000 degrees 1,000 degrees Celsius, which, among other things, would have boiled away all the oceans. So the fact that we still have oceans says this didn't happen. So the fission theory had some serious problems. The nebula theory, one of its competitors, says that the early Earth formed out of a swirling cloud of gas and dust, sort of a miniature version of that solar system thing I told you about, and that the moon just happened to form at the same time as the Earth did. The problems with this, number one, getting a cloud of gas and dust to collapse into two bodies like the Earth and the moon are today has some problems. Number two, why doesn't Venus have a moon? If this natural process happened all by itself, then how come our sister planet, quote unquote, that formed the same way we did, doesn't have a moon while we do? Substantial difference between the two planets there. Number three, the moon's core is proportionally smaller than the Earth's. They should have been the same if this gas-dust thing was where they both came from. And number four, as I already mentioned, Apollo missions showed that lunar rocks are different than Earth rocks, which wouldn't be true if they came from the same cloud. So much for the nebula theory. So the capture theory, the third idea, must have been it then. This idea says that the moon was actually formed elsewhere in the solar system, thus conveniently explaining that inconvenient difference between moon rocks and Earth rocks, and was wandering through the solar system one day and happened to wander too close to the Earth and got pulled into an orbit where it set up nice housekeeping and has been ever since. Problem with that is, where did the excess energy go? It turns out that there's a fairly basic concept in physics that's being violated here. As the moon gets closer, it's being accelerated by the Earth's gravity. By the time it arrives, assuming it doesn't actually hit the Earth, let's say it's off to the side here, by the time it arrives, it will have enough energy to escape the Earth going in the opposite direction. It is impossible for one object to wander on by and get pulled into orbit like this. You have to slow this object down somehow. You have to break it somehow. Well, I won't go into detail on that. But basic problem with this idea is that the physics say it can't happen. And the second problem with this one is that although lunar rocks are different than Earth rocks in some respects, like I said, iron, they are the same as Earth rocks in other respects, in some of their isotopes. So the fact that they're different in some respects torpedoed the first two theories. The fact that they're the same in the other respects torpedoed this one. So at the time Apollo went up, they were hoping to reconcile these three, not reconcile, but find out which one of these three theories was correct. And it's interesting reading the arguments about those theories at the time. Each proponent of each theory didn't say, well, my theory is better because of X, Y, and Z. They all said, well, it can't be your theory because it has problems A, B, and C. So they were all pointing fingers at each other, showing why each other was wrong. So in a sense, they were all right because they were all wrong. Here's a quote from the Time. In spite of everything that we have learned during the last few years, we still cannot decide between these three theories. Notice this is 7 years after Apollo first landed. We will need more data and perhaps some new theories before the origin of the moon is settled to everyone's satisfaction. When a scientist says, I need new theories, what is he admitting about his current ones? All right. Now, as it turns out, right about the same time, actually, in the mid-70s, there was a new theory proposed. Right? That's right. Earth was hit by one of those big asteroids, in this case, a really, really, really big asteroid, roughly the size of Mars, incidentally. It came along and hit the Earth early in its lifespan, if I can apply life to a planet. And the material sprayed out into space. Some of it fell back to Earth. The rest of it coalesced into the moon, where we see it today. That's basically what I just said. Now, computer simulations have proved this to be true. And if you poke around on the web, you can actually see some nice graphics from computer simulations and so on, showing you exactly how all this happened. Well, here's some problems with that. Number one, it's not proof at all. It's just a story, right? I can concoct all sorts of stories, but that's not proof of any kind, right? Number two, it's not even necessarily a good story. Computer simulations are approximations. Trust me on this one, from someone who's written computer simulations on space vehicles and such, you can think your thing is working just peachy and producing all kinds of good results, and no. It's very difficult to write a simulation. Because think about it, you're trying to simulate something that's never been seen, observed, or can't be simulated in any laboratory. How do you know if the computer is producing the correct results? Well, the way you do it is you try to run some test cases through it first of things that you know are right, but a very difficult problem. And computer simulations are by their nature imprecise anyhow, especially when you're modeling things on an astronomical scale. And I won't bore you with details, but that's a whole subject in itself. In this particular case, also, the computer simulation shows that everything had to be just right. You had to have an object of exactly the right size that came in at exactly the right speed and hit the Earth at exactly the right angle for it to even come close to working. So even if it was possible, it's very, very improbable. There's another question, though, and that's why doesn't Venus have a moon? If this all happened by itself because all these asteroids are flying around, right, then Venus, which underwent all the same processes that we did, made from the same stuff at the same time, in the same place, by the same processes, should be similar. Then we would expect it to have some kind of moon, right? If this was so inevitable that we got one. But Venus doesn't. Another problem with it is it requires the moon to have been formed 4.5 billion years ago, which incidentally is the age that you'll hear that the moon is if you look this up. But the moon can't be that old. Here's why. One of the things that the Apollo missions did, other than, they left some things behind besides footprints. And one of them is these light reflectors here. We've left several behind, and the Soviet Union actually, in some of their unmanned probes, left a couple behind too. Here, these are the locations on the moon where these things are sitting. The purpose of these was to be able to bounce laser beams off of them from the Earth and have the light come back. Now, this is a very hard thing to do, as you can imagine. They're doing this today still, and it's successful when they get a few photons of laser light back. I mean, it's a really tough problem. But in so doing, like I said, they have been doing this for years. They've discovered that the moon is actually receding from the Earth. As we've been bouncing lasers off it year by year, we're measuring the amount of time the laser takes to leave and come back. And we've discovered, as I said, the moon is actually moving away from us slowly over time. Let's see, do I have another slide on this? I do. The moon is actually receding from us about 1.5 inches per year. Now, that's not a whole lot. Excuse me. But think about this. If it's moving away from us year by year, then if you look backwards in time, year by year, it's closer to us, right? Now, work that back, and the way the math works in this, actually, why don't I explain how this is working, first of all. It has to do with tides. The moon is out here, the Earth is here, in this high-tech diagram. And this blue thing here is a tidal bulge. Tides are caused by the moon's gravity pulling, in this case the ocean, toward itself, so that the ocean is actually thinner here and thicker here, thus this tidal bulge. Now, what's going on, though, is that the Earth is rotating underneath this tidal bulge. So the Earth, as it rotates, friction between the ocean water and the Earth is going this way and actually pulling this tidal bulge up slightly. Okay? So the tidal bulge is always being pulled up, so the tidal bulge is actually displaced. That's more like over here. Excuse me. As a result, the moon is being affected by this because that bulge actually has a gravitational force of its own, gravitational field, I should say. It's not much, because it's just a big blob of water, but it is having an effect on the moon. If it was lined up with the Earth, like I have my diagram here, then it wouldn't be a problem. But because the Earth is always pulling it a little bit forward, there's more of it over here slightly than there is down here. And so the moon is actually being pulled this way as the tidal bulge is being pulled that way. Does that make sense to everybody? So the moon is actually being accelerated slightly in the direction of its orbit. And the way orbital mechanics work is if you accelerate something in an orbit, if you add energy to it, the orbit gets bigger. So the result of all this is that the moon is moving away from us slowly each year. Like I said, about 1.5 inches or so. But work it backwards. The closer the moon is to the Earth, the stronger this effect gets because the objects are all closer to each other and the gravity is stronger. So if you work it backwards all the way, it turns out the moon would have been touching the Earth just 1.5 billion years ago. And we know that didn't happen. I mean, nobody accepts this, is trying to say that it did. There's reasons it couldn't even get close to the Earth. It would be pulled apart by tidal forces, but that's not important for what we're talking about here. Point is, the moon can't have been in its current orbit doing what it's doing for 4.5 billion years because 1.5 billion years ago it would have been touching us, which would have been bad for it and us, incidentally. One more thing with the moon. For several hundred years now, people have been observing the moon through telescopes and whatnot, and been reporting various things happening. These have been assigned the name transient lunar phenomena, or TLP for short. A TLP is when somebody is looking at the moon and notices something that shouldn't be there. It usually takes the form of a smudge appearing on the surface of the moon that dissipates after a while, or a glow appearing in a region somewhere that goes away, even a flash of light or something. Now, these things only last minutes, maybe hours. They don't last long enough to get a good telescope trained around on the moon and take a picture of it, which is why we don't have pictures of this stuff going on. That's why they're called transient, because they pop up and then they're gone before anybody has a chance to look. Now, for a long time, now, back up a minute. I'm not saying that there's aliens on the moon, flashing spotlights or something. I'm not saying that at all. What people have believed is going on is that there's volcanic activity on the moon, that if you have gas coming out of a vent or whatever, it's going to kick up a big cloud of dust. You're going to have electrostatic discharge, lightning basically, going on inside this cloud to dissipate the charge, and then it all settles down again. So the basic explanation for these things is that the moon is geologically active. There's volcanoes, small volcanoes going off and whatnot. The problem is that the moon is supposed to be 4.5 billion years old. It's old, cold, and dead, basically. It can't be geologically active because something as small as the moon would have cooled off a long, long time ago after it was formed. It can't have energy left over. Now, something as big as the Earth can retain enough heat, and it had more to begin with. So volcanoes on this planet doesn't bother anybody. But volcanoes on the moon can't be there because that would violate the old, cold, and dead description of the moon. However, NASA was finally forced, back in 1968, to come out with this document called the Chronological Catalog of Reported Lunar Events, which documented 579 different instances of TLPs going on. Just for your interest, I have a couple pictures of the places on the moon where these things have been reported. This is the Gassendi crater, and the Aristarchus plateau especially have had quite a few of these incidents reported for them. Again, we don't have pictures of these things happening, which would be nice if we did because it would diffuse this whole debate. I mean, there it is. But apparently it's very real. The problem is it violates the old, cold, and dead principle. Well, maybe it's not old, cold, and dead after all. So here's what you aren't being told about the moon. There's problems with its origin, severe problems. Trying to explain how this thing got there is not at all what you're being told. Lunar recession says it can't be billions of years old because 1.5 billion years ago it would have been touching us because it's moving away today. And transient lunar phenomena also say that apparently it's not old, cold, and dead as it is supposed to be. So the moon is uniquely designed for us, basically, as a summary of all this. Actually, I just put this in there because I like the picture. So, next planet out is Mars. Are we going too fast? Am I throwing too much detail at everybody? Yes? No? No? Okay. Next out is Mars. Mars is one of the few objects we have actually landed spacecraft on and sent back pictures. Here is what the Martian landscape, at least in one location, looks like if you were unlucky enough to be stuck there. Mars has turned out to be a planet of extremes. As we've explored, we found some really interesting things. This is a volcano called the Olympic Mons. It's the largest volcano in the solar system. Its base is the size of the state of Missouri. That's a big volcano. We also see dust storms that cover the entire planet. Here's an example of two photographs that were taken, one in June and one in September. The one in June, this is where it was clear and you could see lots of things. Then a global-wide dust storm kicked up and obscured everything. So you can see what a difference that makes. Violent weather on Mars. It also has the biggest canyon in the solar system. The Mariner Valley is this thing here. It puts the Grand Canyon to shame. This thing is the length of the continental United States and almost 6 miles deep and multiple times wider than the Grand Canyon. Tremendous canyon system stretching across Mars. Now, the big question in the news that whenever Mars pops up is, was there water on Mars? Some of the photographs we get back, I mean, it looks like there's water erosion that forms some of these things. We see what may be like little streams. We see what appears to be runoff here, and so on. You can go through this and find lots of features that look like they were formed by water. Here's another example, the Eberswalde crater. The crater itself is this thing, but I'm going to show you a close-up of that little box right now. It looks like this. Now, this looks kind of like a river delta, doesn't it? Like at the mouth of the Mississippi or a large river that's been depositing sediment in this big triangular-shaped forms. That's kind of what this looks like. It looks like a big drainage thing for a river, doesn't it? Problem is, we're seeing some other things happen that look like, or that otherwise we would think were formed by water, but we know they're not because we've been watching. This ridge here, for example, here's a picture of it in 2002. 3 years later, we see that this erosional feature here has formed, and we know that's not, I mean, if you didn't know, you'd think it was liquid water because it looked like water runoff, but we know there's been no water there. So it's being formed by other erosional means. There's also photographs like this circulating in the media where they say, well, look at all those layers of sediment. You know, sediment was obviously laid down by water, so therefore Mars used to be underwater at one point, or at least large portions of it were. Now, why the big ruckus about water? Well, evolutionists love to speculate about water on other planets. You may or may not have noticed this in the news because they do the same thing. Since life obviously formed here by itself, but needs water to do so, well, if we find water elsewhere, that might mean life elsewhere too. And life elsewhere would confirm evolution, right? Maybe there's even intelligent life elsewhere, more highly evolved than us, so we can go learn from these ascended masters. Yeah, the New Age stuff works in evolution big time. Well, the Martians must be awfully thirsty because liquid water on Mars is actually physically impossible. Mars has a very thin atmosphere today, and as a result, even though it's very cold, the boiling point of water is very low because of the thin atmosphere. And if you did have a puddle of water, it would boil away in a few hours. You can't have liquid water on Mars. The problem is evolutionists want water on Mars really badly. In fact, some want enough water to flood the entire planet. This creates a problem, doesn't it? You see, Mars used to have a bigger atmosphere, enough to accommodate water, but then a long time ago an asteroid came along, smashed into Mars, stripped away the atmosphere, and it's left with what we have today. Now, this is total hypocrisy. Think about this. There can't be water on Mars. We know this. I mean, we've had spacecraft there taking samples and taking pictures. But they want a global flood there for various reasons. Therefore, they had this asteroid that created a one-time catastrophe. On the other hand, Earth is covered with water. There's more than enough to have a global flood here, but we're mocked for believing in one because catastrophes are unscientific. Another factor here is that a lot of the so-called water-like features on Mars have other explanations. For example, there's a thing called a thermokarst, whereas when you have ice in the ground, if it melts, the ground collapses in such a way that it looks like water ran off. And I showed you the example also of the gully that's been eroding as we're watching with no water being present. So we've seen a lot of these things form without water, yet they insist that there must have been water there anyway, even though there can't be. Also, we've taken soil samples by some of our probes, and we found only trace amounts of carbonates, like limestone, which would have indicated that water used to be there. In other words, we're looking for things that were, for chemicals that would be formed by water if it was there, and we're not finding them. On the other hand, we are finding minerals like olivine which break down in the presence of water. So we're finding chemicals that are telling us water didn't used to be there either. So here's what you're not being told about Mars. Next time you hear a news story about all the evidence we're finding for water, maybe there's life there. First of all, the so-called evidence for water has other explanations. It doesn't have to have been water for those features to be there. Number two, water is impossible there today anyway, and saying that it used to be there is hypocrisy because of the way they criticize us for believing in a global flood in a planet that's covered with water. How are we doing so far? Is everybody awake? Okay. I'm worried about showing you pictures of the night sky, late at night here. I mean, people be nodding off. Okay, next out from Mars are the planets called the gas giants. There's Jupiter, Saturn, Uranus, Neptune, and you are here. Not right next to it, but just for purposes of size, to show you how big these objects are. The first one is Jupiter. Jupiter is sometimes called the king of the planets. It is by far the biggest. Jupiter is famous for this feature here called the giant red spot. This is a huge storm going on in Jupiter's atmosphere. It has been there for as long as we have been observing the planet. So for all we know, it might have been there since creation, thousands of years. Or it might have just started a couple hundred years ago. We don't really know exactly, but it's been there as long as we've been looking. To give you some perspective, here's the Earth compared to the great red spot. So imagine a tornado bigger than the Earth. That's what this thing is. Now, Jupiter provides a unique challenge to evolution. I told you about the fact that planets can have various times of rotation around their axis. It takes the Earth 24 hours to get around our axis. Jupiter spins on its axis once every 10 hours. Imagine something this big spinning around in 10 hours. That thing is just screaming. But the problem is, under an evolutionary scenario, how do planets spin? Why do they have spins at all? Well, because as these rocks were forming and aggregating into these big planets, of course, the rocks would come in various directions because this is all random, right? I mean, there's no intelligent creator, steering any of this. So the rocks are going to come in at different directions, different angles, different speeds. And sometimes they'll hit on one side, which spins the planet this way. Sometimes they'll hit on the other side, which spins the planet around the other way. So in general, all these impacts should more or less cancel each other out, right? Because it's all random. So it actually turns out to be kind of difficult to get a planet spinning at all in these evolutionary scenarios, much less to get something this size spinning around that fast. Here's a quote from an evolutionist who's been working on the problem. We came to the conclusion that if you accrete planets from a uniform disk of planetesimals, prograde rotation, prograde meaning in the expected direction, prograde rotation just can't be explained. The simulated bombardment, all those rocks flying in that I told you about, leaves a growing planet spinning once a week at most, not once a day. So Jupiter should not be spinning around as fast as it is unless there was some sort of non-random element to all these rocks coming in, but that's out of bounds because that would interfere with evolution. Another question, where did Jupiter come from? Here's a quote from Nature Science Update. Jupiter is the largest of all the planets, but results in nature now reveal the embarrassing fact that we know next to nothing about how or where it formed. As we've sent space probes to Jupiter and sampled its atmosphere, and I shouldn't say sampled, measured its atmosphere, it turns out that the things we expected would be there aren't, and stuff that isn't supposed to be there is. Jupiter was supposed to match the predicted composition of that early cloud of gas and dust. I mean, since Jupiter formed out of that cloud and it's basically a big ball of gas still, then the gas should match the gas that it came from, but it doesn't. So Jupiter's composition doesn't match the predictions of the nebula theory. Jupiter also has some really interesting moons. We could spend the whole evening, actually each of these things we could spend a whole evening on. But here's a small sampling of some of the puzzles that Jupiter's moons have provided for evolution. This moon is called Io. It's a little tiny thing. Let's see, do I have... There's a picture in here. Well, it's later on. A picture of a shadow of one of these moons so you can see how small they are. These moons are tiny compared to Jupiter. Io is this weird-looking thing here. And we didn't think much of it until we flew the Voyager spacecraft by it in the 1980s. We found some very strange things on Io. Io is covered in enormous volcanoes. This one here has been named Tvashtar. And look at the size of this thing. I mean, compared to the planet itself, that's a substantial fraction of the surface just for this one volcano, and Io has others besides these. Since we have been observing Io for 20 some odd years now, Io has been constantly covered in a series of volcanic eruptions, which is what this thing is. These things go 200 miles into space. There's some violent eruptions, and it's not just one, it's a series of these, like over a dozen. And when one stops, another one starts elsewhere. These have been continuous for as long as we've been observing the moon. The problem is Io is tiny, and it's also 4.5 billion years old, right? So it should have been cooled off a long time ago, the whole old, cold, and dead principle. Io shouldn't be geologically active, but apparently it is. Its neighbor is a moon called Europa. Europa is the smoothest body in the solar system. It's mostly covered with ice. You'll hear lots of reports in the news, excited reports that there may be water under this ice. And of course, where there's water, there's life, and where there's life, there's aliens, and they're more evolved than we are, right, or whatever. Io has some interesting looking terrain here. As you see, these are cracks in the ice surface. Right next door to Europa, though, now like I just said, Europa was the smoothest body in the solar system. Right next door is the most heavily cratered object in the solar system, Callisto. Now, if these things formed at the same time in the same place in the same materials and the same processes, they should be roughly the same, but they ain't. And you can't blame it on different compositions either, because both moons are roughly 1/2 ice. Also, Europa has a core where Callisto apparently doesn't. These two objects are very dissimilar from each other. Then there's Ganymede, which is larger than the planet Mercury, actually. Ganymede is covered with this weird grooved terrain. All these grooves all over the surface, with the occasional thing where someone took a paintbrush or something and smoothed it all out. Here's a broader view of that. Bizarre stuff on the surface of Ganymede. I'm not saying I have an explanation, by the way. I'm just saying they don't. They'll talk about tectonics and so on. Oh, and by the way, Ganymede also has a magnetic field that shouldn't be there. Other moons cause problems too, like Amalthea is a little tiny one right in close to Jupiter. Jupiter's moon supposedly formed out of its own local cloud of gas and dust, which would make Amalthea a rock, but instead it's an ice ball. It's the opposite of what it was supposed to have been. And we could spend a lot more time on Jupiter's moons, but time is limited. Just remember what you're not being told about Jupiter. It can't be spinning as fast as it is. It can't be made up of what it's made up of. Io appears to be young. Ganymede can't have a magnetic field, and the moons cause other problems as well. Are you seeing a trend here yet? Is there, good news for evolution, any of this? Next up from Jupiter is Saturn. Now, of course, Saturn has the famous rings. This is the planet most people think of when you think of astronomy or a planet. Now that we have the Cassini space probe around Saturn, we've got some beautiful pictures of the structure. The rings look like they're just one big object from here with maybe this stripe in the middle, but it turns out there's actually millions of these things. Each one is its own little ring, and the ring is composed mostly of little chunks of rock and ice. There's a few moons scattered in there too and a few boulders, but mostly it's very tiny material, all orbiting around Saturn all together. And each of these has its own name, and some astronomers specialize only in studying this stuff. But, oops. One of the problems, though, is that these rings are apparently young. By young, I mean not billions of years old. Evolutionist says, after all this time, we're still not sure about the origin of Saturn's rings. Astronomers once thought that Saturn's rings formed when Saturn did 4.8 billion years ago, as the sun and planets coalesced from a swirling cloud of interstellar gas. But lately, he says, there's a growing awareness that Saturn's rings can't be so old. Here's why. The rings are bright and shiny, obviously, we just saw in that picture, but they sweep up space dust as Saturn goes around the sun. This space dust would darken those rings after just a few 100 million years. The fact that they're still bright and shiny tells us that the few 100 million years hasn't happened. There's also the fact that the moons outside the rings and ring material are exchanging angular momentum, basically one slowing down, one speeding up. Eventually the moons will actually be flung away from Saturn while the outer half of the rings will fall toward the planet. That doesn't happen in very long of a time either, so since it hasn't happened yet, again, the rings must be young. But we know Saturn is old. So where do these young rings come from? Anyone want to guess? Right. You're all getting the hang of this now. Kuzi speculates that some hundreds of millions of years ago, a time when the earliest dinosaurs roamed our planet, Saturn had no bright rings. Then, he says, something unlikely happened. A moon-sized object from the outer solar system might have flown nearby Saturn where tidal forces ripped it apart, or maybe an asteroid smashed into one of Saturn's existing moons. The debris encircled the planet and formed the rings we see today, etc. The rings have other things that are really puzzling. You see these lines going on here. The rings have spokes. Now, keep in mind, these aren't rings. This is just chunks of material all orbiting Saturn at the same time. Why would it have spokes? Some of them are braided. No one predicted this. Imagine this. I mean, the rings are braided. Weird stuff. It's almost like a creator created this so we could scratch our chins and say, nah. Recently, when we were looking at the rings, we noticed something else with one of Saturn's moons. This is Enceladus, and the screen really does not do this picture justice. I think the lights are too bright here. Is there a way we can turn some of the lights down, or is it too late for that, probably? That helps a little bit. Yeah, there we go. So here is a moon called Enceladus. Notice this thing on the bottom of it. When we take a closer picture of Enceladus, we see this. It's a pretty moon all by itself. But the interesting thing happens when you take a picture of it from behind, where the sun is on the other side of it from where you are, because then you see that Enceladus has geysers shooting off of it. The moon looks basically like a deflating water balloon. You open a water balloon and squeeze, and the water squirts out. That's what this thing looks like. In fact, when you process the image a little bit more to see how big these geysers are, you see they're quite substantial. In fact, there's been some other weird stuff going on with Saturn's rings. They think the material is coming from Enceladus and being added to certain of Saturn's rings, causing some of the changes we've seen. The problem is Enceladus is far too old to be doing this. It should not be geologically active anymore. Maybe it's not old? Nah. Now, you can say, well, maybe there's some sort of inherent characteristic to the moons that would have it do this. Well, its next-door neighbor is the same size, Mimas, and not doing this kind of thing at all. This is sometimes called the Death Star moon, by the way, as you can probably guess, by this big impact crater. Something walloped it pretty hard and caused that crater. But my point is, Mimas and Enceladus, same size, one is doing very different things than the other one. Then there's Titan, another moon of Saturn, which, as you can see by the fuzziness, has an atmosphere. Now, Titan's atmosphere was mostly made up of methane, and when the Cassini probe arrived, scientists were excited to go study this moon finally and figure out some of our theories about the atmosphere were true. The problem with having a methane atmosphere, if you're billions of years old, is that methane is broken down by sunlight. So Titan's atmosphere can't last very long. It gets broken down quickly. Therefore, the prevailing theories were that Titan has seas of methane all over it to constantly replenish this methane atmosphere. The problem is when we got there and actually started poking around beneath the clouds, there ain't no such thing. So evolution is expected to find seas of methane on the moon, and they are not there. So that atmosphere should not be methane after all these billions of years. Then there's the crowning touch. Two of Saturn's moons dance. What do I mean by dance? These two pieces of rock that you're looking at orbit Saturn very close to each other. A few tens of miles apart are their orbits. One is bigger than the other, as you can see. But my point is, one of these is further away from Saturn than the other one is, and every so often they swap roles. The one that's in the outer orbit moves to the inward orbit, and the one that's in the inward orbit moves to the outward one. And then they orbit Saturn like that way for a while, and then they swap again. Dancing moons. Neat stuff. So here's what you aren't being told about Saturn. The rings are young, Enceladus is young, Titan is young. There's dancing moons, there's weird stuff going on in the rings. It seems to me the Creator is not only skilled, but he appreciates beauty. Next out from Saturn is Uranus. Now, I wish I had a nicer picture to show you, but we don't have any. Uranus is a fairly featureless ball of blue-green. which is why it was interesting when we first got close enough from the Voyager spacecraft to start taking some measurements, and we got a surprise. First of all, Uranus has some rings. They're very faint. This image obviously took some computer processing to show all this stuff. And we also were able to show that Uranus has some bands in its clouds. The surprise is that it's all going the wrong way. Notice this ring goes up and down. I don't have the photograph rotated. This is how it actually is out in space. Whereas all the other planets rotate more or less in an up and down direction. In other words, that they spin like a top as they go around the sun. Uranus is sideways. It rolls along like a ball as it goes around the sun. Now, this does not match that swirling cloud of gas and dust model that we talked about. You were supposed to have the bigger cloud all go in the same direction, and then smaller local swirls would form going on all the planets. Remember, that was one of the proofs of the theory, right? Because all the planets are going in the same direction and doing all this nice, neat stuff. Well, as we study them a little closer, they're not doing that at all. So this creates a real problem for evolution. Now, who wants to guess? Right. Uranus formed the way evolution predicted, you understand, but then a big rock came along and hit it and knocked it over. Anybody detecting a trend here? Models for the development of the solar system cannot produce such an orientation, that laying over on the side business, without invoking a collision with another object. The problem is that Uranus shows no evidence whatsoever for such a collision. First of all, Uranus's orbit is one of the most circular of all the planets, showing no evidence of having been walloped hard enough to knock the whole thing over. I mean, remember how big Uranus was compared to the Earth? Big object, right? You need a huge collision to do that. Also, Uranus's orbit lies more closely within the ecliptic plane than any other planet except Earth, again showing no evidence of such a catastrophe in the past. You also have a problem with the moons. The moons, back up a minute, the moons of Uranus all orbit this way. In other words, they used to be this way, but when the equator got moved, when the whole planet got pushed over, the moons are here now. Now, you have a question. Well, did the moons form before or after this supposed collision? If they formed before, how did you move them from doing this to doing that? Which you can't, obviously. But if they formed after, well, how come they're orbiting the equator here and not some sort of chaotic pattern as a result of the spray pattern of fragments that came out, which they supposedly came from? You also have a problem in that if you say they were formed after the collision, then all of the moons combined are only 0.1% of the mass of the planet. And the collision that was invoked to explain the Earth's moon has the moon being 1.2%. So you see there's a real discrepancy between the model, the collision that supposedly produced the Earth's moon, and the collision that would have had to produce Uranus's moons. Basically, the moons shouldn't be there doing what they're doing. Other problems that this planet presents. Why doesn't it radiate energy? All the other gas planets do. Jupiter, Saturn, and Neptune all radiate more energy into space than they get from the sun. Uranus doesn't. If these things formed at the same time, in the same place, in the same materials, in the same processes, why ain't they doing the same thing? Worse than that, quote, to the complete astonishment of scientists, the magnetic axis of Uranus is tilted approximately 60 degrees with respect to its axis of rotation. It is not known why. In other words, the magnetic field for this planet is causing problems, just as all the rest of them have. In this case, it's because the magnetic field is not lined up with the planet's rotation. And as the cherry on top of the cake, the axis is also offset from the center of the planet. Uranus has some moons. One of this is Miranda, which one of my favorite objects in the solar system, I think. Maybe I can convince you to believe that as well. Miranda is a tiny object. It's only about 300 miles across. But look at all the different kinds of terrain that are in this little tiny object here. You have grooved terrain up here with a very neat boundary, which I guess the big screen isn't really showing up all that well. You have heavily cratered terrain here, lightly cratered terrain here that's smoother. You have coarsely grooved terrain down here. You have cliffs over here, which I'll talk about in a minute. You have like a trapezoid here with very sharp edges and a big check mark in the middle of it. Like the creator said, let them figure this one out. Maybe it's space art. I mean, look at this. Nice, smooth terrain, and then, I mean, you can almost draw the line here, like someone ran a paintbrush down the edge of it. It also has the highest cliff in the solar system. It's about 6 miles high, this thing right here. Imagine standing on the edge and looking down. Now, if you were the evolutionist trying to explain how this thing formed all by itself, how would you like to get this job? Just in this one picture, you get the paintbrush thing up here, you get the check mark here, the different colors, and like I said, look how sharp that line is. We don't normally see sharp lines like this in nature. People draw them, but things like this don't usually happen by themselves. So pity the poor evolutionist who has to explain this thing, really. No one predicted anything looking like Miranda. Well, there's an understatement from an evolutionist. Another guy said, the central problem in modeling the thermal histories of the Iranian satellites is accounting for Miranda. Who wants to guess the answer? Yep. Let's see, I click the button. Okay, here's your tax dollars at work. Here's a quote from a NASA website. Scientists believe that Miranda may have been shattered as many as 5 times during its evolution. One collision couldn't do it. We need 5. After each shattering, the moon would have reassembled from the remains of its former self, with portions of the core exposed and portions of the surface buried. And then the author has a wave of guilt and is actually honest and says, Miranda's appearance can be explained by theories, but the real reason is still unknown. So they're saying you got to break this thing up and reassemble it 5 different times. Another guy notes that although some sort of collisional disruption appears to be required, it is not obvious that the present terrain, with relief up to 20 kilometers, would survive catastrophic disruption and reassembly. He's saying that dramatic terrain I showed you with all the cliffs and all the rest of it, he said if you smash this thing into pieces, then you're not going to have this type of thing afterwards. So here's what you aren't being told about Uranus. The sideways rotation disproves evolution. Its magnetic field disproves evolution. It should be radiating energy, but isn't. And Miranda is a complete mystery. Next up is Neptune. How are we doing on time? How old is Neptune? 4.5 billion years old, right? More or less. It's old, cold, and dead, just like all the rest of the things you've been looking at. None of the above, as it turns out. Neptune is the furthest large planet from the Sun. It's 30 times as far away as Earth is. So it's in a very cold place. But it isn't cold. It radiates twice the energy into space that it receives from the Sun. Nor is it dead. That spot right here, the great spot, has disappeared since the first time we started taking pictures. Neptune's atmosphere is changing. It's very dynamic. It's acting very young, not at all like something that cooled off billions of years ago. In fact, Neptune is actually the most violent place in the solar system. We've clocked winds there at 1,300 miles an hour. Can't even imagine what that would be like. And there's yet another magnetic problem for evolutionists posed by this planet. In 1986, the Voyager probe discovered Uranus's magnetic field was tilted and offset, like I mentioned a few minutes ago. At the time, scientists suggested that Voyager had caught the field in the middle of a reversal, which is when the magnetic poles switch places. So maybe that explained the weird field. But then 3 years later, Voyager visited Neptune and found out that Neptune's field is doing the same thing. So it seems that the possibility of finding 2 planets both experiencing these reversals is small. In other words, you can invoke a miracle on the first one, but you can't invoke the same thing happening at the same time for someone else. Now, it's interesting because creationist physicist Dr. Russell Humphreys had successfully predicted the strength of both of these fields before they were measured by basing his model on the Bible. Based on 2 Peter and some other passages, he postulated that all the planets were originally formed out of water. That would have certain implications for their original magnetic field, which would have caused leftover remnant magnetism today. And they all laughed at him because his predictions were 100,000 times greater than evolutionist predictions, but it turns out when we actually got there, he was right, they were wrong. Oh, and by the way, neither of those planets we've been talking about, Uranus and Neptune, they don't exist. Here's a quote from Astronomy Magazine. Psst. Astronomers who model the formation of the solar system have kept a dirty little secret from you. Uranus and Neptune don't exist. Or at least computer simulations have never explained how planets as big as the 2 gas giants could form so far from the Sun. Bodies orbited so slowly in the outer parts of the Sun's protoplanetary disk, that gas and dust disk, that the slow process of gravitational accretion would need more time than the age of the solar system to form bodies with such big mass. Now, you'd think 4.5 billion years would be enough time, wouldn't you? Nope. What is clear is that simple banging together of planetesimals to construct planets takes too long in this remote outer part of the solar system. The time needed exceeds the age of the solar system. We see Uranus and Neptune, but the modest requirement that these planets exist has not been met by this model. By the way, everybody I'm quoting in this presentation is evolutionist. I meant to say that up front, and I forgot. So, I mean, you're hearing admission straight from the people who actually believe this stuff. I like that. The modest requirement that they exist hasn't been met. Well, then what good's your model? Now, how long has this problem been known? There have been many attempts to model the evolution of a swarm of colliding planetesimals. Safronov calculated the characteristic timescales for planetary growth. I won't read all this. He says around Earth it would take 10 million years. 10 million years. But the further out you get from the sun, it gets longer and longer. When you're at the Neptune, it's 10 to the 10, which is 10 billion years, which is more than twice as long as the 4.5 billion years that they actually have to play with. It is clear that in view of the large timescales found for the formation of the outer planets, a satisfactory theoretical model for the accretion of planets from diffuse material is not available at present. Now, when did Safronov first do these calculations? Is this recent news to everybody? No. He did this in 1972. We've known for over 30 years that those planets aren't there, except that they inconveniently are there whenever we look. Now, you'd think this would be a problem. It's clear that our level of sophistication of studying planet formation is relatively primitive. So far, it's been very difficult for anybody to come up with a scenario that actually produces Uranus and Neptune. Who heard about this on the Discovery Channel last week? Anybody? No, we have it all figured out, right? Evolution explains everything, right? No. Now, that last quote really reveals the heart of this whole matter. It's been very difficult for anybody to come up with a scenario. That's really the name of this whole game. If you can come up with a scenario, that's all you need to do. Evolutionists seem to believe that the mere act of coming up with a story proves that it all happened that way. Right? I mean, that's the logic they use. They run a computer simulation. Oh, look, we have it all figured out. Here's exactly how it happened. Because they were able to build a model that maybe produces what we see. Well, they can't build a model anyway, as we've seen. But even if they could, it doesn't prove anything, right? It's a computer model. It doesn't prove what happened one way or the other. In fact, as we've seen, it's not only a matter of coming up with a story. It doesn't even have to be a good story, really. Because think about what we've learned tonight. Rather than acknowledge their creator, evolutionists would rather cling to a story that denies the very objects it's supposed to explain. You would think that they'd realize this isn't a good alternative. Now, why is this the case? Well, the creation-evolution thing is really a spiritual battle. Man is sinful. We want to shake our fist at the Creator because if we acknowledge Him, then we acknowledge sin, we acknowledge responsibility, we acknowledge judgment, and all these other things that we don't want to deal with. Rather than deal with that, we're going to cling to a story that says these things can't be there. So here's what you aren't being told about Neptune. It looks young. The winds, the dynamic storms, the heat, its magnetic field defies evolutionary fables, and the biggie here is that evolution says it can't exist at all. Last planet is Pluto. This is an artist's conception because we don't have good photographs of this thing. It was formerly believed to be an escaped moon from Neptune because evolutionary theory says that there shouldn't be a planet doing what it does out where it is. The problem with that has always been that there's actually two objects here. There's Pluto and its moon Charon, which is very big compared to Pluto. And we recently discovered there's two more moons here. So it's getting kind of awkward to say that an escaped moon itself has multiple moons. What you aren't being told about Pluto, well, there's not much here because we don't know much about the planet. The big thing is nobody knows what to do with it, or is it a them? I mean, here's Pluto and here's the main moon. Is this an escaped moon? Is it a planet? Is it a double planet? Is it something else entirely? Well, we're not sure. We don't know. Other objects include comets. Comets are a good argument for a young solar system. Some of you have probably heard this argument before. Comets are basically dirty snowballs that orbit the sun. This is a photograph of the Wild 2 comet that was recently visited. This is about 3 miles across to give you a sense of the size of this thing. Basically a dirty snowball going around the sun that as it approaches the sun each time, it heats up and these nice beautiful tails are burned off away from the sun as it travels through space. Now, if you think about these jets of material coming off, That means that the nucleus of this thing is getting smaller each time it visits the sun, which is the heart of what I'm about to tell you. Comets come in two flavors. There are long-period comets, meaning they take more than 200 years to orbit the sun. There's also a lot of short-period ones, which orbit in less than 200 years. And the short-period ones are the important ones for our discussion tonight. These comets, because they visit the sun so frequently, burn out quickly, or at least quickly, quote-unquote, in evolutionist terms. They can't last for hundreds of millions of years, never mind billions, because they burn up. So why are there still so many short-period comets left orbiting the sun if the solar system is 4.5 billion years old? They've come up with explanations about how there's this reservoir of comets out in space, and a place called the Kuiper Belt and another place called the Oort cloud. The problem is, as we're studying those places, well, the Oort cloud you can't see anyway. The place that we can actually measure is the Kuiper Belt, and the few things that we're finding there are far too few and far too big to be comets anyway. So what you aren't being told about comets is that there is no proven source for short-period ones, which there should be if the solar system is billions of years old. If the solar system is thousands of years old, then it's fine, because there hasn't been enough time for these things to burn up. However, that's not what they want to believe. What's the bottom line of all this? Here's a quote from one of my astrophysics textbooks. Thus far, we have seen that we know very little about the development of the solar system. Well, thank you very much. To sum up, I think that all suggested accounts of the origin of the solar system are subject to serious objections. The conclusion in the present state of the subject would be that the system cannot exist. Can you believe this would be satisfactory to someone? The Bible, on the other hand, tells us that the heavens declare the glory of God, and the firmament shows his handiwork. And I think that's a more appropriate way to look at the sky. One thing I want to say briefly, actually a couple things. I first put together an astronomy series for a church 10 years ago. And it was a 13-class series. What you just saw was one class. So this level of problems can be found. In that class, I started at the Big Bang, and I went all the way forward in evolutionary history, step by step. Like I said, this is one out of the 1 out of the 13, excuse me. So if you imagine this level of problems with each step along the way in astronomy, we're only scratching the surface about how we're being, I don't want to say deceived, but we're being misinformed about just how well evolution explains everything up there. Another thing, too, if you're relatively new to the creation viewpoint of things, all I've discussed tonight is one small segment of astronomy. I'd like to make the point, though, similar problems exist in all the sciences: paleontology, geology, botany, zoology, anthropology, on and on and on it goes. This level of difficulty for evolutionary explanations is everywhere. What we're being told in the secular media is not at all what the actual information is in many cases. So, do I have time for questions, Chris? No, I don't. Okay, I've been shut down. Good night.